Hello, guys. Good evening. Hi, guys. Good evening, everyone. So, today we'll be seeing about parabola, like everything that you need to know about parabola. That is what we'll be seeing. Okay. So, in today's class, we mainly in conic sections, you have different types, right? In conic sections, you'll be learning about ellipse, parabola, hyperbola, and many more, right? So, same way, we will be mainly dealing with the parabola concept here, like everything that you need to know about the parabola. Okay, so yes, let's quickly get into the video. Yes, so yeah, so now let's start what is a parabola. So parabola is basically, what is the definition of parabola? Let's see with it. So, a parabola refers to an equation of a curve. So, it is generally referring to an equation. So, generally, parabola or ellipse or hyperbola, it will be dealing with the equation of a curve. Generally, that is the equation of a curve such that point on a curve is equidistant from a fixed point. So the point on the curve is equidistant from a fixed point. You are having a curve, for example. I'm not drawing the diagram of parabola and explaining you. First, I'm explaining you with the theory part, then I'll be explaining you with the diagrams. So basically, you'll have a curve and you'll have a point on a curve. So each point, you can have many points. So for example, you'll be having a point here, you'll be having a point here, here. So point on the curve is equidistant from a fixed point. So the point in the curve is equidistant from a fixed point and a fixed line. Okay, so that's how you draw the curve, and that's how the equation of the curve is formed. Okay, so what do you call that fixed point as? You call that fixed point as focus of the parabola, and you call the fixed line as the directrix. So for example, this is your axis. Sorry, let me draw like this, so that this is your axis. And what is your fixed point? My fixed point is called my focus. So from the fixed point, whatever point you go to in the curve, that will be equidistant from the fixed point. Okay, so from this fixed point, wherever you go, okay, that will generally be equidistant from the fixed point. And what about the fixed line? Okay, this is the fixed line. So fixed line is called the directrix. Okay, so it will be equidistant from the fixed point and fixed line. So basically it will be like this. Okay, so basically you are having a straight line, and this is your parabola, and this is your fixed point, sorry, fixed line. From this will be equal to this point. That is what they are saying. And this will be equal to this point, and this will be equal to this point. So from the line, like, basically what they are saying is equidistance from fixed point and the line. So from here to here, it is equidistant. So any point you take on the curve, from that point you go to the fixed line. Okay, and you go to the focus. The distance from the point and the focus will be equal to distance from the point and the fixed line. Okay, and here the fixed line is called directrix. So basically distance from directrix to the point on the curve will be equal to from the point on the curve to the focus. Are you clear? So this is the main definition of a, or you can call it as a property, main property of a parabola. Okay, generally locus of any point which is equidistant from a given point and a given line is called parabola. The same definition they have this is given as a raw definition, but here, yeah, so this here they have given as a raw definition, and here this is a, you know, compact, a proper definition which you can have it for a parabola. Okay, so this is what a parabola is. Now let's see, before going to the equation of parabola, generally a parabola will be a quadratic equation. So parabola will be a quadratic equation. So this is generally a quadratic equation. So quadratic equation of a certain form. I'm not telling any quadratic equation is parabolic equation. No, quadratic equation of certain forms only I'm talking about. So that is called the parabola. Like generally just remember that parabola's equation will be having the highest power of parabola's equation will be having 2. Okay, now let's go to the next one. So here, what is the equation of parabola? So equation of parabola, the general equation is given by y is equal to a into, so basically y is equal to a into x minus h the whole square plus k. That in general, like actually how can we write it as y minus k is equal to a into x minus h the whole square. Like this we can write it. Okay, otherwise you can write, otherwise this is the general equation. Otherwise how can you write? You can write in terms of x also. X is equal to a into y minus k the whole square plus h, right? So how can I rewrite it? I can rewrite it by taking my h to the other side. So x minus h the whole, x minus h is equal to a into y minus k the whole square. So basically what am I trying to tell is, generally your equation, any equation, here h comma k denotes. So generally your equation, if your parabola is in x in the vertex 0 comma 0, you'll be generally having an this is right side open parabola. Generally it is y square is equal to 4x. Like this it will be there. Same way, if your parabola is here, okay, this is h comma k. So basically how can you write? So you can write it as y minus k the whole square is equal to 4 into a into x minus h. So like this you can write. So these are the general equations, which is an advanced, like, you know, this, if this is confusing, just remember in different way. How are you supposed to remember is, so if this is your, you know, straight line, and this is your parabola which is having in the vertex h comma k, just this is a parabola which is opened in the rightwards. Generally parabola can be opened rightwards, leftwards, upwards and downwards. Okay, so if it is opened rightwards, how can you write? So basically it is y square is equal to 4x. That is what the general equation of opening rightwards. So here I can write x minus k the whole square is equal to 4 into x minus h. So this is a parabola which is opened rightwards and having a vertex at h comma k. So this is called, this is the equation. Now let's go to the next one. So when I do the next one here, basically it is, so yes, just a minute. Okay, so yeah, so yes. Now let's learn about, before learning about the types of it, let's learn about the terminology. Here just remember this point alone. This point alone you remember, the standard equation of a parabola. Only that point you remember. Other things let's see. So here terminologies. So terminology, what is a focus? So now let me explain, let me explain the theory first, then I'll be explaining with the diagram. Okay, so a point a comma 0 is the focus of a parabola. So if this is your parabola, this point. Okay, so if this is your parabola, this point is called your focus. Okay, see, as I have given here, no, this particular point is called your focus. Okay, so that is a comma 0. This is a parabola which is opened rightwards. I'm just talking about rightwards parabola. So here in general I'm talking in rightward open parabola. A parabola which is opened rightwards. For that, your focus is this one, a comma 0. Now what about the directrix? How do you draw the directrix? Okay, so basically a line drawn parallel to y-axis. You should draw a line parallel to y-axis and it should pass through a point minus a comma 0 and is the directrix of the parabola. So generally what they're saying, you should draw a line which is parallel to your y-axis. And where should the line pass? It should pass in minus a comma 0. And that line is called your directrix. Okay. So, and this is also for your parabola which is opened rightwards. So, here this line is nothing but x is equal to, because it passes through minus a comma 0. So as it passes through minus a comma 0, you can say x is equal to minus a. So the equation of line is nothing but x plus a is equal to 0. This is your equation of the line. Okay, so this is your minus a comma 0. Okay, so and this line is your directrix. So what is the what does directrix mean? Which means, see, I told you it is parallel to your y-axis and it passes through minus a comma 0. Then what do you say? That is your directrix of a what? Rightward open. Suppose if it is upward open. So if this is your parabola and you're drawing a line, so here basically be 0 comma a. This is your focus and your directrix will pass through 0 comma minus a. Okay, in this case, if your parabola is open upwards or downwards, your directrix will be what? Your directrix will be parallel to x-axis. But if your parabola is open leftwards or rightwards, generally your directrix will be parallel to x-axis. So let me before write. So types of parabola. So generally, how can you say? You can say that it is open. So open rightwards, which is basically like this. Then what you can say, open leftwards. Okay, how can you say that? It is basically like this. Then what you can say, open upwards. Then what can you say? Then you can say that it is open downwards. So open downwards is like this. Okay, so for if your parabola is open upwards or downwards, your directrix will be parallel to your x-axis. If it is open leftwards or rightwards, your directrix will be parallel to your upwards or downwards parallel to x-axis, leftwards or rightwards parallel to y-axis. Are you clear? Yes. Now, let's go to the next one. So here, what is a focal chord? Okay, so focal chord, so here one more point, directrix is perpendicular to the axis of parabola. So yeah, you can see right here, it is perpendicular line. It is not just like that any line, it is a perpendicular line. Okay, so now let's go to the focal chord. So what is a focal chord? Focal chord of a parabola is a chord passing through focus of parabola. So it is a chord which passes through the focus of parabola. So the focal chord cuts the parabola into two different points. So generally it is a chord which is passing through the focus, and that chord cuts the parabola into two distinct. So this PSQ is your focal chord, and it cuts your parabola into two distinct points. Okay, so this is your focal chord because it passes through the focus. So that's why you say it is a focal chord. Okay, now what about the focal distance? So focal distance of x1 comma y1 from parabola from the focus is the focus distance. So you're having a point in the suppose this is your parabola and you're having a point on the parabola, say x1 comma y1, distance from x1 y1 from the focus. So basically if this is A and the focus is B, so your AB is your focal distance. So look here, I told x1, y1. See here, I'm keeping the point as P of x comma y. So P of x comma y is the point on the focus, point on the parabola. From that point to the focus is our focal distance. Okay, from the point to the focus is our focal distance. Okay, now the focal distance is also equal to perpendicular distance from the point of directrix. So what I'm saying is you are having the focal distance, no? So from this point you draw this is your directrix, you draw a perpendicular line. Okay, so I'm calling it as C. So the distance from A to C will be equal to distance from A to B. See, the focal distance is equal to perpendicular distance from the point from the directrix. So that is called that is also there. So this is my directrix and this is my perpendicular distance. Okay, so distance from P to M, okay, is equal to distance from P to S. This we have already seen in the starting of our introduction, right? Starting of our class. So basically the distance from focus to the point on this parabola is equal to distance from the directrix to the same point on the parabola. So PS will be equal to our PM. That is what I am going. That is what is given here. Now, so yeah, let me quickly erase this. Yes. Now, what about the latus rectum? So, latus rectum is a focal chord. What is a focal chord? It passes through focus. A chord which is passing through focus. So, it can be any chord. That chord I have drawn it as diagonal. No? So, when you see here, it is actually a slanting line. Okay. But it still passes through the focus. So, it is a focal chord, right? But here, the focal chord that is perpendicular to the axis of parabola. So here you have to draw it in such a way that it is perpendicular. You're drawing a perpendicular line from both the ends of parabola, and still it passes through the focus. In that case, what can you call the line as? The line is called latus rectum. So it's passing through the focus of parabola, and that particular line is called latus rectum. The length of latus rectum is equal to L dash, L to L dash, that is equal to 4A. So basically the end points of latus rectum, which means you know this is A comma 0. I'm talking about, already I told you, I'm talking about a parabola which is open rightward. So this here they're telling it is A comma 2A, and this point they're telling A comma minus 2A. So the distance between the points is nothing but is A comma 2A and A comma minus A, that is 4A. So basically this is my point A comma 2a, and this is my point a comma minus 2a. So a perpendicular line passing through the focus is my latus rectum. So my L dash is equal to 2a plus 2a, that is equal to 4a. So this is my latus rectum. Okay, so 4a is my latus rectum. So what is my eccentricity? So eccentricity, now let's talk about our eccentricity. So eccentricity E is equal to 1 is the ratio. What is eccentricity? It is a ratio of distance of point from focus to the distance of point from directrix. So basically, if you take, as I already told you, this is thing, I'm taking it as PSQ. Okay, so distance of a point from the focus to distance of the point from, so distance of the point from the focus to distance of the point from directrix, that is equal to your eccentricity. So generally your eccentricity here will be 1. So this is what they're saying, distance from point to focus divided by distance from point to the directrix will be equal to our eccentricity, and that is generally equal to 1. So parabola's eccentricity is always equal to 1. That is really important. You definitely have to know it. Okay. Now, so see, so I have in general given for everything. So this is open, rightward, leftward, upward, downward. So this is a parabola which is opened. So these are the points. So when your vertex, so this everything I'm talking for a vertex 0, 0. Okay. So vertex is this one only. So this is the vertex. The point where it meets the major axis, that is the vertex. Okay. So, okay. So for all the parabola, I'm talking for 0, 0 only. So focus here is a, 0, it is minus a, 0, 0, a, and so on. So same way, your directrix will also change, your equation of axis will also change, and your latus rectum is same for all the things. Okay. So yes, now let's quickly go. So these are the standard, I hope it is clear. These are the standard explanation with your directrix line is x plus a here, and this is a standard for y square equal to 4ax. Same way, this is y plus a here. Basically, it is y plus a, that is equal to 0, and same way it is, and here it is what, x minus. So here x minus a is equal to 0. That is how we'll be doing. And this is open leftwards. And here this is y minus a is equal to 0. That is what you'll be doing. Okay. So this is for your x square is equal to minus 4a. Why? So now let's solve the sums for it. So here, see what are they given? They gave you that equation of a parabola is equal to y is equal to is basically y square is equal to 224x. Okay, find the length of the latus rectum and focus and vertex. So now let me compare this to, for what am I comparing? I'm comparing this to which equation? Y square is equal to 4ax. I'm comparing this to the equation because it is similar, no? So this is a parabola which is opened rightwards. So I have to write that also. So this is parabola open rightwards. So this is the parabola which is open rightwards. So if I compare this, what can you say? My 24 is equal to my 4a, right? So when your 24 is equal to 4a, I am equating 24 is equal to 4a. So what about my A? That will be 24 by 4. My A will be 6. So generally, so I know if a parabola is opened rightwards, what will happen? So focus is generally a comma 0. So focus of the point is 6 comma 0 is my focus. And what about my h comma k? So when I compare h comma k is your vertex is 0 comma 0. Since if you're having if you're having any vertex apart from 0 comma 0, you'll be having something here, x minus something or y minus something, like that you'll be having. But in this case we didn't have. So what can I conclude? That my vertex is 0 comma 0. What about my latus rectum? Just now I told latus rectum for everything it is 4a. So basically it is 4 into 4 into 6. So basically it is 24. So 24 is my answer. Okay, so 24 is my answer. Are you clear? Now I have found the latus rectum, focus and vertex. Now let's go to the next one. So here, equation of parabola, find the length of the latus rectum, focus and vertex. Equation of parabola is there, no? So basically I have to write it. So 2 into y minus 3 the whole square plus 24 is equal to x. So how am I going to write it? I will be substituting and seeing. So I know a equation of a parabola. So compare with this one. Let me take this to the other side. 2 into y minus 3 the whole square is equal to x minus 24. So here what can I say? I can say y minus 3 the whole square is equal to 1 by 2 into x minus 24. Like this I am writing. Now what am I going to do? I am comparing. So compare with this equation. So compare with equation, general equation. So y minus k the whole square is equal to 4 into x minus h. This equation I am comparing. This is y square is equal to 4x, which is opened rightwards only with vertex h comma k. Okay. So here what am I going to do? My 4a is equal to 1 by 2. What about my a? So yes, so I'm taking this to the other side. So yeah, so what about 4a is equal to 1 by 2? Yeah, so this will be a is equal to 1 by 8 is my focus. So now what happens? The point, now what happens? I have to find the h comma k. So this is my focus. A is my focus. So basically my focus will be, so focus will generally be a comma 0. So which is basically 1 by 8 comma 0. That is how it will be. So now what will I do? Sorry. Yes, 1 second. So it can't be 0. So basically your h comma k will be like this. So this will be, so this point will be 3 here. So basically my focus here will be a plus h comma k. That is how it will be. That will be your focus for of a vertex which is having h comma k. So basically my a is 1 by 8. What will my a be? So basically what is my h? So h is 24 plus, so that is my h. H is nothing but 24 plus 1 by 8 comma 3. So here when I further do it, after adding, it will be 193 by 8 comma 3. So this is generally my focus. Okay, because the focus for this one is generally for h comma k vertex. Now when I further do here, I have to find the lattice rectum. My lattice rectum is 4a, which is 4 into 1 by 2. So for 4 into 1 by 8, that is nothing but 1 by 2. So 1 by 2 is my lattice rectum. Now what I should do, I'm having vertex. So vertex is basically my h comma k. So here h is nothing but 24 comma 3 is my vertex. So yes, that's all about your parabolas concept. So I have completely explained you all the theory part of parabola and I've solved few sums. So if you have any doubts, do comment below and do tell me what is the topic which I should take for the next time. So yes, thank you and have a great day.